Hello everybody in Year 12. This is a presentation for solving literal equations. Mainly the exercises come from 2B, so I thought I'd just pick out a couple and see whether we could work through them and help try to address some concerns you might have. So if we have to solve for x and the equation's here. Now when we have a fraction equaling a fraction, usually I find it works best if I can cross multiply and get everything onto the top line and I don't have to deal with fractions. So that's what I'll do here. So I'll put that up to there and that up to there. So that'll become 1 times x and b times by x plus a. So 1 times x would be x, and b times x would be bx, and b times a would be ba. Now let's see, I think I might take that across to there. So that means we'll have x minus bx is equal to b minus a. And because I've got the x's in two spots, I'll factorize them to get them into one spot. So if I do that, I'll divide by b minus 1, and I'll do that, dividing by b minus 1. Those will cancel out, and I'll end up with x is equaling to ba minus 1 over b, and I've solved it so that it's all in terms of x. Alrighty, let's try another one. Now here's another one that I want to solve. I have mx plus n is equal to dx plus e. Now if I want to solve for x, and I do, I've got an x on this side of the equation and an x on this side of the equation. It helps if you get all your unknowns in one spot. So that's what I'll do. I will take the dx and I'll minus dx on both sides. And I'll take this n and minus an n on both sides. That will mean I'll have mx minus dx, the plus n and the minus n will cancel out, and the dx and the dx will cancel out, and I'll end up with e minus n. Now I've got the x's on the one side now, but in two different spots, so I'll factorize, and that will mean I'll have x bracket m minus d, e minus n. Now what I'll do is I'll divide and m minus d on both sides, so that cancels out and that cancels out, and that leaves x on its own. So I get x is equal to e minus n over m minus d, and that's the final answer to this. Alrighty, let's try one more, which is a bit more tricky. Okay, so if we want to use this equation and solve for x and get x all in one spot with everything else on the other side, well, here's how I think we should do it. Now we have a pair of fractions equaling to another fraction. Well, how do we add fractions? We get a common denominator. So what we'll do is, that'll be the first thing. So we'll times by a plus b on the top and bottom of this first fraction. And for this second fraction, we'll times by a minus b. And that way we'll get a common denominator that is the same on both of these fractions. Now, let's see what happens. Well, a minus b, a plus b, a plus b, a minus b, those are both the same as a squared minus b squared by difference of two squares. So what I'll do is I'll write all this on one fraction and then cancel out the two fractions themselves because they're all going to be the same. If I expand a minus b, a plus b, I get a squared minus b squared. And if I got a plus b, a minus b, that'll expand out to a squared minus b squared. And then, if you notice, I've got the same denominator on both sides. Now I can just cancel those out. And after I've done that, I'll expand both these brackets. So xa plus xb plus 2xa minus 2xb. Now the next thing I'll do is I've got an x and an x and an x and an x. I'll take out each of those x's and factorize it. So I'll have a plus b plus 2a minus 2b. Now let's see. A plus 2a is 3a, and b minus 2b is minus b. Now if I divide on both sides by 3a minus b. That will cancel out there.